Hello students, so I'm back with another interesting question, and this is a paragraph type. I'm showing the question, do give it a try. It is a bit long, but go step by step, go fundamentally, and you'll get to the answer. So I'm showing the question now. So this is the question. The question starts with phenol, and there is a series of reactions, one after another, and we have to identify each of the products. Pause the video, give it a try, and comment down your answer, and then we shall proceed with the solution. Now, to proceed with the solution, we have been given phenol as the starting substrate, and it is reacted with a dilute HNO3 in the presence of H2SO4, that is a mixed acid, and therefore from here we shall get two products. One is orthonitrophenol and one is paranitrophenol. Now in the second step, it says that the mixture of ortho and paranitrophenol is steam distilled and the compound A is the more volatile compound. Now as we know, this compound orthonitrophenol exhibits intermolecular hydrogen bonding, as a result of which it is more volatile than its para isomer. As a result, this shall be a required compound A. Now in the second step, we are reducing the NO2 group, which forms OH and NH2 in the second step as our final product B. From there, B is reacted with NaNO2HCl, so it forms a diazonium salt, which is C. Now C is reacted with warm water, so what we get is catechol. So this is our compound D. Now D is further reacted with an interesting reagent, which is BH3 in a THF medium. The THF is taken because BH3 does not exist independently, and it exists as a dimer well known as B2H6, and therefore THF produces a complex which is something like this, and helps to abstract BH3 as a single unit from the dimer B2H6. So here we are reacting catechol with BH3, and as BH3 is electron deficient species, it forms a ring with the two oxygen possessing lone pairs, and we get something like this. So this is a compound E. Now this compound E is then reacted with propene. So this reaction will proceed according to the much known mechanism of the hydroboration oxidation method, where an alkene is oxidized to its corresponding alcohol according to the typical anti-Markovnikov reaction mechanism, and this in the first step adds to the alkene like this, and this hydride gets transferred. So here is the minus, so this is the plus, and the hydride is transferred, which forms something like this. And please note, the addition of the hydride is syn, so a syn product would be formed if asked about the stereochemistry. Here it is irrelevant because there is no chiral center as such. So this is a compound F. Now F, when it is hydrolyzed or treated with H2O2 specifically in the presence of base NaOH, the OOH bond attacks the B boron in its vacant shell, and this gets removed and this attaches itself here. So we get the corresponding propanol as a typical anti-Markovnikov product, and this leaves after 3 times of reaction as BO3 2 minus or borate ion, and we get back catechol, which is our compound D. So these are all the compounds that has been synthesized in this entire process. Do go through the solution and tally your answer, and comment down whether you got the correct answer or not. And this was all for today's video. Keep watching, and I'll be uploading videos more frequently now, almost daily. So do make sure to tune in every day to get more such interesting videos. Keep learning.